One place you can use variables is in connection managers. In this case, you can customize the behavior of a connection manager by using a property expression for the connection string. Instead of hard-coding the database connection string as part of the connection manager, you can store it in a variable and use that variable in the property expression. This provides flexibility in database connections, allowing actions such as looping through a list of databases on a particular server that performs some action on each database. Or you can customize a file location for export. So there's different ways of doing that within different kinds of connection managers. Another component where you can use variables is a derived column transformation. This is one of the transformations within a data flow. This transformation can add new columns to the data flow or replace existing columns with the value of an expression. And so that figure shows how you can create a column named formal name that's the concatenation of the variable salutation. So that's a variable within the package or the data flow or whatever, and the last name column of the data flow. Now you're not limited to simple string concatenation either. Integration Services expressions support a rich subset of T-SQL functions and operators for creating expressions with variables. All right, another transformation you can use variables with is the conditional split transformation. This is an interesting one because it directs rows in the data flow to different paths based on criteria that you define within an expression. You could use a conditional split transformation to route rows based on an expression that includes a column from the row. So, for example, if you're transforming monetary data, you might define a variable called limit and set it equal to $100. If the data flow has a price column, you can send all rows greater than the limit value to a table called expensive and all rows less than the limit to a table called cheap. And the way you do that is by placing the conditional split transformation in the data flow and creating an expression on it that keys off the price column and whether the column is greater than or less than the value in that limit variable. And that way, you can easily change the limit value in a central location or even set it in another task or transformation, such as reading the value from a database or maybe calculating the average of all recent orders or wherever you want that information to come from. So the bottom line is that this gives you a lot of dynamic flexibility in routing a data flow through the data flow pipeline. Something else you can do is that in transformations that allow SQL strings as input, you can write queries with parameter placeholders, and it would look something like this. So select star from production.product where product ID equals question mark. And then you can map a variable to the placeholder within that query. Now, a really important example of use of variables is within property expressions. These property expressions provide a way to assign a dynamic value through the form of an integration services expression to a property. And what they allow you to do is to set object properties at runtime based on values that are acquired or calculated or evaluated during package execution. And then property expressions let you create flexible packages with data-driven behavior. And that's the key concept here. You can actually change behavior based on the data that's contained within variables. And so when combined with variables, you have an extraordinary level of control and flexibility with packages. All right, now, many integration services tasks have an expressions page in their editor dialog boxes where you can set up property expressions. Otherwise, in the Properties window, which you access by pressing F4 with an object in focus, you can click the ellipsis button in the Expressions property in order to bring up the Property Expressions editor. All right, and so this shows the editor for the Execute SQL task, which is accessed from its Expressions page. Now, different object types in integration services have different methods by which you access property expressions. Control flow objects like tasks, containers, and connection managers expose their property expressions through their object editor dialog boxes or the Properties window. As you explore packages more deeply, as you gain experience with integration services, you'll continue to find more nooks and crannies where you can use property expressions. It's a very rich feature that's built deeply or baked deeply into integration services. Now, you can access the property expressions of data flow components pretty much in the same way as control flow objects. But not all data flow components support the use of property expressions. So there's several data flow component properties where you can use property expressions, and this is not an exhaustive list. You can use them to set the timeout property in the SQL destination component, set the header property in a flat file destination, use the sampling value property in row sampling and % sampling components. You can set the SQL command property in the OLEDB command component, and use XML data property in the XML source component. So that's just a few of the places where you can use property expressions. And in the example that I'm going to show you shortly, I'm actually going to use the sampling value property to dynamically set the number of rows that are returned from a table and exported. Now, as you can probably imagine, there are many ways to use variables and parameters in a package, ranging from the mundane to the clever and complex. So what I'm going to do now is show you a simple but comprehensive example of how to make use of variables and parameters. In this exercise, I'm going to create a package that reads rows from an AdventureWorks table and exports a sampling of them to a flat file. A parameter is going to contain the path of the folder where to save the file, and a variable will contain a random number of rows to export. The control flow will take care of creating the folder if it doesn't already exist. Now, because there's no random function that's built into the expression language of integration services, the package is going to use a script task to generate a random number to determine how many rows are copied to the output file. Okay, so here I am within SQL Server Data Tools. I'm going to create a new project. And I'm going to call this one Using Variables. I'll create it. Okay, and I'm going to rename the package to Using Vars. In this case, I wanted a different package name from the project name just so it's clear what context I'm working in. All right, so the first thing I need to do in this new project is to create a parameter that's going to hold the folder path for the export file. So to do that, I'm going to select the Parameters tab for this package level parameter and click on the Add Parameter button there that adds a new line. So it's much like creating a new variable within a package, but Parameters gets its own tab within the designer. I'm going to name the parameter folder path, and the data type needs to be string. So I was just hitting the S key until string showed up. And then I need to set the value to a valid path. Now, it doesn't matter whether the path currently exists, as long as the drive letter and the path name is a valid path name. Okay, so I'm going to use C samples customers. Okay, there's no sensitive information that's contained here, and I'm not going to require that the user change the parameter. And so I'm all set with that new parameter. One thing in Real Package I might want to do, though, is add a description for what's required in this parameter, just so it makes it easier to use and you remember, you kind of document what the parameter is for. Okay, I'm going to come back over to the control flow here, and I'm going to add a file system task to the control flow. So I'm going to use this component to create the folder that I just specified in the folder path parameter. So I'll double click on this to open up its task editor. And the first thing I need to do is change the operation to create directory. As you notice, the list of properties that are available changes based on the operation. I'm not quite sure why Microsoft didn't put that at the top, because that's really kind of the first thing you need to do before you configure things, but so be it. Okay, I'm going to change the name here to create folder. It's always good to name tasks to identify what they're doing. Okay, then notice I have this isSourcePath variable property. It's currently set to false. That indicates that I'm going to use a connection, going to create a connection manager. But I'm going to set that to true, and notice that the source variable property appears because I'm going to specify the location where I want to create this directory using that variable. It's actually a parameter, but parameters and variables are equivalent in this particular case. Okay, so I can come over here to the drop-down list and notice that I have this parameter. Parameters are identified with a $sign and its scope, its namespace, and folder path. But I can create a new variable, I can use a system variable, whatever. All right, so I'm going to select folder path there. Another thing I want to do is change the value of use directory if exists. So I'm going to change that, double click on it to change it to true. This will prevent the task from failing if the directory already exists. And so now I can run the package multiple times, and if the folder already exists, this task doesn't do anything. So that's cool. All right, I'll click on OK, and notice that the red X is gone. Also notice that I didn't create a connection manager as part of configuring that task, because the information, the folder location, is within that variable that I specified, actually, again, the parameter. But in this context, it's now functioning as a read-only parameter, a read-only variable. All right, next thing I need to do is create variables that are going to hold the number of rows in the table and the random sample size value that the package is going to generate. So I'm going to use the number of rows in the table in order to bound the random number that's generated. So if there's only 1,000 rows in the table, I don't want it to select 10,000 rows. And then the other variable will contain the random number that I generate that's going to be the number of rows that I return. All right, so I'll go to the variables window here, and I'll select add variable. I'm going to change this to sample size, and I'll leave the other properties set to their default values. And keep in mind that the default here is an int32, so it's an integer. And then I'll repeat the process, and I'll create a row count. And I'll also leave the default values there. All right, so that variable, so the sample size is going to hold the random number, the sample of rows, the size of the sample that I want to retrieve from the table. And the row count is going to contain the number of rows in the original table. Before I go any further, I just want to kind of step back and kind of take an overall look. Now, you might be tempted to give these variables the scope of the data flow task that I'm going to create. The data flow task is actually going to read the data from the table and export it to the file. And the reason that's tempting, and I know it's tempting because that's the original way I started designing this example, is because the variable is only going to be used within the data flow, strictly speaking. The stuff in the control flow is really housekeeping. I'm going to use the sample size variable in the data flow. But the problem with doing that is that then you have to generate the random value in the data flow as well, using a script component. The problem is that then you'll generate a random value if you put it in the default location within that code for each row in the data flow pipeline, potentially hundreds or thousands of times, when in reality you just need a single value each time the package executes. Now, there is pre- and post-execution code that you can write as well, but it just is overkill to put that kind of code within a data flow and have that script component hit every time a row is processed. It's just not very efficient. So in this scenario, it's best to make a package variable and generate the random number once, a single time within the control flow. But a downside is that you'll need to determine the number of rows in the table in the control flow as well, instead of using a row sampling task or a row count task within the data flow. Okay, so we have our two variables, and now we need to find out how many rows are in the source table. So I'll come over here to the toolbox, and to do that, we'll use an execute SQL task. And I'll set the precedence constraint there, like that, and double-click on the execute SQL task to open up the task editor. All right, I need to create a connection there, so I'll select New Connection. Now, if I didn't have any connections defined within this instance of Data Tools, I'd have to create one. But in this case, But in this case, I already have a connection to the AdventureWorks LT 2012 database, so I'm going to use that one. If I didn't have it, I click on the New button, create a new connection. All right, I'm going to leave the SQL source type to direct input because I'm going to type in the SQL statement here. And now I need to specify this SQL statement. I'm just going to do a select count star as number of rows from salesLT dot customer. Okay, so this is a fairly simple select statement, so I just typed it in, but I could also open up the ellipsis button there, have a little bit more room to create a more complex statement, or I could use this build query in order to build a query using a graphical user interface. Okay, so lots of ways to put in SQL. Easiest for short statements is just to type it in. Now, one thing about this, notice that I have an alias for that count aggregation because I need to reference this when I hook this up with a variable. So I'm going to do that in just a moment. So at this point, if I stopped configuring the task now, the execute SQL task would execute that SQL statement, but the results would just disappear into the ether. So I need to save the count result to that row count variable that I created within the package. So in order to do that, I need to come over here to the results set page and click on the add button. Results set. Okay, what didn't I do? That is disabled. Let me go back over to general here. So I have a connection type, connection, direct input, SQL statement. Oh, what I forgot to do is right here. So what this property does is it specifies the format of the query results as it says there. So this is saying that there's no result set brought back. And that's why there wasn't an add button, because there's no results to map to a variable. So what I need to do is change that to single row. But notice that I can also process a full result set if this is going to return multiple rows. Or if it's going to return XML, if I'm using the XML features of SQL Server, I can select that as well. So it's going to return a single row, happens to be a single column as well, but single row, and that takes care of that. Come back over your result set, and now I can click the add button. Okay, so what this is doing is I need to map the column in the results to a variable. Keep in mind this is configured for a single row. So what I need to do there is I gave that alias, that count aggregate variable, the alias number of rows. Notice there's no automated way, there's no drop-down list to provide lists of those, so I need to very carefully type it in so I don't do any typos, because that will cause an error in the package. And then I map it to the variable. And so row count sample size, there's only 2 there. And in this case, the default, it happens to be alphabetically first in the list. So row count is the variable that I want to map that to. So when that SQL statement executes, it's going to put the count of the number of rows into that variable that I created. Okay, cool. That task is now configured, and so I can close the task editor, and we're good to proceed. Now I need to generate a random sample size to use. And to do that, I need to use a script task. Because remember, there's no random function within the expression language of integration services. Now in this case, the precedence constraint is important because I need to find out how many rows are in that table before I generate the random value, because I want to bound it by the number of rows. So I'll drag the precedence constraint right there and double click on that to open up the task editor. Okay, one thing I do want to do is change the name of this. I could have done that on the task itself, but I'm going to do it here within the general page because I've already opened it. And so this is called Generate Sample Size. And I can add some sort of a description. Okay, I'll come back over to the script page here. I'm going to write C# code, so I'll leave that. Next, what I need to do is to indicate that the task will be reading the row count variable, reading that number of rows in the table, and then updating the sample size variable. All right, so I'll select Read Write Variables, select the ellipsis, and check Sample Size. And again, I could have typed that in if I wanted to. So I'm going to write to that variable. But then I'm going to read from the row count variable. Now, because these are the read-only variables, it includes a list of all the system variables that are available. But in this case, I'm going to select row count. because I just need to read that value. I don't need to write to it. All right, that configures the script task editor. Now I need to write some code. So I'll click on the edit script, and that'll open up the Vista development environment. And once again, I need to change the contents of the main method. And all I'm going to do here is generate a random number. So I'm going to use the random object. I'll name that variable rnd equals new random. And then I'm going to create a rows integer variable. I'll use that rand, get the next value. And I want the range of values to be, let's scroll down, that's actually the overload I'm going to use. I'm going to set the minimum value to 5, just a random magic number because I want at least a few rows. And then I'm going to use the row count value in order to give the upper bound. So I'll use DTS variables. Actually, there's one other thing I need to do, but I'll do it this way first. So variables. The name of the variable is user row count. I need to access the value property and go there. Okay, so now notice that I have red squiggly. The reason is because the parameters here need to be integers. And so as you can see, the best overloaded method match for system random next int has some invalid arguments because this is not returning an integer. This can return any kind of value. It doesn't know, the collection doesn't know what kind of data integration services or the data type integration services has assigned to row count. That information isn't passed along. So all I need to do is cast it to an integer. So I'll do that, and now we're good. Okay, so now rows is going to have that randomly generated number of rows that I want to read from the table. Now I need to write that value to sample size. So I once again use the dts.variables, and this time access user sample size and value, and assign it the value of rows. Okay, hit Control S, save that code, and that's all we need to do. So this is going to update the value of sample size, and there you can see where I read the value of row count in order to generate the next random number and then write that to sample size. All right, that's all I need to do for that script task. Click on OK, and now we're good to go for the generate sample size task. Okay, with all that, we're finally ready to add the data flow task. So I'll add that to the control flow and set the precedence constraint. Now the precedence is important because I need to get the size, the number of rows in the table, generate the sample size before I start reading that data. Okay, I'll double click on that to open up the data flow designer. And then the first thing I need to do here is create a connection to the AdventureWorks LT 2012 database in order to get data from the customer table. So this time I'm going to use the source assistant, so I'll double click on that, and that opens up the source assistant to add a new source. All right, I want a SQL Server source type, and I can create a new connection manager there. So I can double click on it, as the message says down there, in order to open it. But in this case, I already have a connection there. But I'll just double click on that, and all that's going to do is open up the connection manager where you can define a connection to that database. But I've already got one of those, so I'm going to use that. I can check the parameters there. They look good. Okay. And so that creates an OLEDB source with the connection manager right down here. But as you can see, I still need to configure the OLEDB source because I need to tell the component what data I want to retrieve. I have a connection to the database, but it has no information yet about what table's data or what kind of data I need from that source. So I'll double click on it, and that opens up the OLEDB source editor. Now, to keep things simple, I'm going to retrieve the entire contents of the customer table. But you could also define a SQL statement in order to limit the data that's retrieved. And notice that I can use a variable that contains the SQL command as well. But I'm going to leave it for table review, and I want to select the salesLT.customer table right there. And if I want to, I can click on the preview button, see, yep, that pretty much looks like the data that I want, and I can see up to about 200 rows of that. All right, that tells the data that I want, and I'll click on OK, and now the red X is gone and we're good to go. So at this point, the data flow is set up to produce the full set of rows from the customer table. So it's time to take a sample of the rows that are equal to the number of rows that I set in the sample size variable back in the control flow. And that's the job of a row sampling transformation. Now, there's different ways of doing this. You could use different SQL tasks to do it and so forth. But row sampling is a real easy way to do it, although there's a little bit of a twist to it that I'm going to show you. So come over to the toolbox and scroll down here, row sampling. Oops. Sometimes it doesn't like to move things around very readily. So there we have a row sampling, and I'm going to connect it to the data flow, this blue arrow, coming out of the OLEDB source. And so now row sampling has the schema of the rows, the columns and the data types of the information that it's going to get. So I need to configure this. Now, as you can see, there's only a few properties that you can set here. The transformation produces two outputs. One is for the row selected by the sampling process, and another is for the unselected rows. And so you can set the names of those right here. I'm going to leave the defaults because they're good enough. But maybe you're going to select something here that is something more specific to your particular data. But the important thing here is that there's going to be two data flows coming out of this component. And I can use both of them. I can use one of them if I want. In this particular example, I'm only going to use the selected output because I only want the subset of rows. But if I needed to do something with the rows that weren't selected by the sampling process, that random process, then I could use this flow, this output flow as well, and break off and have two flows going through my package. Okay, if I wanted to, I can also use a random seed in order to change the randomization process that is used for selecting the rows out of the table, because it really is selecting random rows. It's not just going to select the first X rows. It's going to randomly select the rows up to the number that I specify right there. And as the warning down here says, is using the same random seed on the same input data always generates the same sample. Specifying random seed is recommended only during the development and testing phase of a package. So you have a consistent set of rows, get everything working, and then either test it more with random rows or put it into production and let it start working with real world data. Okay, so I'm not going to use that in this example. Okay, so I skipped this one right here. What's interesting about this is that there's a number of rows. I can go up, I can go down, but there isn't any obvious way of using my variable in order to set that value. So there's no apparent way of doing that. And in fact, there is no way to do that within this transformation editor dialog box. The only option here is to set a fixed number. So I'm going to use another technique to set the value. So I really don't care what this is set to within the dialog box. I'm going to do this outside of this dialog box. Okay, so let's take care of that problem. I'm going to use a technique of using a variable to set a custom property of data flow transformations called property expressions. The row sampling transformation has a sampling value custom property that I talked about. So I'm going to right-click on an empty area of the data flow designer and select properties. And that opens up the properties window here. Or I could have gone just directly to it over here in the side. What I want to do is select the expressions property right there. Now if I expand that, notice that it doesn't have anything within it. This is actually a collection property, and I need to click on that ellipsis button there to open up this property expressions editor. So the first thing I need to do is specify the property that I want to set. And happens to be at the top, it's the row sampling value property. So that's the property that it's going to be set by the expression that I specify. So the expression that I want to use, I can use the expression builder here, but in this case, I just want to indicate that I want to use the value of a variable. So to do that within an expression, I use the @ sign. I'll talk more about that later. And user : sample size and closing bracket. So what this is going to do is when this transformation executes, it's going to look at the value of that expression, which is going to be the value in sample size, which is going to be from 5 to the number of rows in the table, and assign it to that property that's going to override that 10 from the transformation editor dialog box. And I'll click on OK. And as you can see, if I expand it now, we now have this mapping that you can see right there. And so I can do multiple mappings here within this properties. And keep in mind that this isn't the property window of the row sampling transformation, it's the property of the data flow task as a whole. So I may have multiple expressions that I'm mapping that affect multiple components within the data flow. At this point, we have the row sampling. It's going to pull out the number of rows based on the sample size that I created. And so now all I need to do is generate a flat file with that sample of the rows. So I'll come over here to the toolbox, go down to destinations, and I want to use a flat file destination. I'll connect the data flow there to the flat file destination, and notice that I get this dialog box, input output selection. Remember I told you that row sampling, this transformation right here, has two different outputs. So I have to tell it which output that I want to use and put into this flat file. Do that drop-down list. I want the selected output, but those are the names that I defined. I used the defaults, but those are the names defined within row sampling. I just as easily could then create another destination for that unselected output as well. Now, one thing that might be a little confusing about this dialog box is this output input. Keep in mind that you're actually configuring this data flow. It's not fully formed yet, but it's that data flow. So the output is from the previous component, so you want to use the output from row sampling, you select that, which turns out to be the input into this flat file destination. So that's the reason that those are named the way they are. That can be kind of require a double take in order to figure out what is going to what. So just be aware of that. Okay, so notice that now I have that sampling selected output, and it helpfully tells me which output that is. And notice that I have output coming into this flat file destination, or data flow coming into this flat file destination. Now I need to configure it. So I'll double click on it. And I don't have any connection managers, so I have to create a new one. And I'm in a data flow, so I need to specify the format of the destination flat file. I'm going to use delimited, but I can use fixed width or fixed width with row delimiters or ragged right and so forth. This is going to be a typical comma delimited file. So I'll click on OK there. And that opens up this connection manager editor. Okay, so first thing I need to do is specify a valid file name. Unfortunately, this is something, remember I created that parameter that has where this is going to be located. There is no way to directly use that parameter value here. So what I need to do in order to make this flat file connection manager editor dialog box happy is put something valid in here. So I'm going to type in c /bogus/bogus.text. Okay? So that makes the editor happy. But I'm going to overwrite the value with the value of the parameter that I created. I'll do that a little bit later. All right, I also want to check this value right here, column names in the first data row, so it outputs those as the first row. Okay, that's all I need to do to configure this. But just keep in mind that I have bogus information here. I don't have a bogus folder. I'm not going to create one. I'm not going to create a bogus.txt. But this makes the editor happy. And it's good when editors are happy. Okay, so I have this flat file connection manager. Notice that I have this option to overwrite the data in the file. I'm going to leave that checked because I want to be able to run this package multiple times and just have the data within that file, have it refreshed each time, as opposed to adding new rows to that file each time I execute the package. Okay, notice I still have a warning. I have to map the columns on the mappings page. I'm going to accept all the columns. I'm going to use the destination columns with the same name. I don't have to do anything here, but the editor really wants you to look at the mappings, and so I did that, and now the warning message is gone. All right, so that configures that flat file destination. One last thing I need to do is now use that parameter value to specify the location of the file that I want to output and the file name. So I need to do that by changing the properties of the flat file connection manager. Not the destination itself, the connection manager, because this is the component that defines the location of that file. All right, I'm going to go over to the properties window there. And I need to use an expression property to set the actual location and the file name. So just like before, I'm going to use the expressions property here. And keep in mind that this is now not the entire data flow. This is sort of, strictly speaking, outside of the data flow, even though it's part of the designer. And so I have the flat file connection manager, not the flat file destination. All right, I'll expand that. See, there are no expressions for that component. And so I'll click on that right there, and I have that same dialog box. So in the property here, I want to specify the connection string. And that's a little bit of a misnomer. Databases have connection strings. Files have paths and file names, but it's all called connection string for the purpose of a flat file connection manager. And this needs to be the fully qualified name. And then I'm going to add an expression here. I'm going to specify the @ sign that indicates it's a variable in the expression, even though it's a parameter. And here's where I'm going to use that package. Definitely need to spell it right. Package folder path. So that's going to write in the value of that path that I put in the parameter, but then I need to define a file name as well. So I'm going to use the concatenation operator and use a fixed string of customers.text and close that off. And make it a little bit easier to see, I can widen this a bit and widen that. Whoops. I double clicked on that, but that's no good. Okay. So there you can see the full expression. I'll hit enter. All right, so at runtime, it's going to evaluate this expression, read the value of folder path, concatenate on customers.text, and I'm pretty sure I included the trailing slash. Hopefully I did. Otherwise, go get an error. And so that's going to update the value of connection string, and so it's going to write out the file name that we want in the location that we want. All right, I'll click on OK. And we've configured that property expression. All right, we're finally good to go. Kind of a complex package, a lot of moving parts. But now what I can do is, first of all, I'll go over here to Windows Explorer, and I'll go into Samples. And notice that I don't have a customers folder here. Okay, this is the equivalent of showing you that there's nothing up my sleeves. All right, come back over here and start package execution. Go out, compile it, execute things, and as you can see, it read the data. It read 847 rows. And in this particular execution, the sample size was 29 rows. So I can go back over here. Now there is a customers folder, and there's a customer.txt. If I open that up, you can see, unfortunately, Notepad doesn't have an easy way of telling the number of rows, but yeah, that looks like about 29 rows. Cool. I can come over to the package, stop execution, run it again. In this case, the folder already exists, so it's not going to create it again. I still get 847 rows, but this time the sample was 505 rows. Come back over here, open up the file again, and there's a lot more rows in the file. Okay, 505 to be exact if you were to count them all. Okay, now there's one little funky thing going on here. Notice that all of the data flow tasks execute successfully, but according to the control flow, something went wrong. So as usual, you can come over here to Progress, and there you can see the result of the expression, user sample size on property, row sampling value cannot be written to the property. The expression cannot be set on the property. Now, this apparently is a bug. When setting the sampling value property using the property expression. It is being set successfully. We get the random sample size and so forth. The data types are correct. They're both int32s. Sampling value is an int32 value, and sample size we defined as an int32. And so as near as I've been able to determine, that's just a bug in the property expression, apparently just for that specific property. So everything does execute successfully, but be aware of that one little gotcha about this.